Okay, let's look at this problem and see if we can factor it. Notice it's given that 1 is a 0 of multiplicity 2. That means when we do synthetic division with 1, it should work, and it should work twice. So let's try synthetic division with 1. Now in this case, because they told us the 0, we don't have to use the rational 0 theorem. We can go straight to division by 1. So we put this here, bring down the 1, multiply, add, multiply, add, multiply, add, multiply, add. So notice, whoops, sure enough, we got a 0. Remember, once we have this, we can factor this. It was x to the 4th, so now this is x to the 3rd plus 5x squared plus 52x minus 58. Now we need to factor it again. And now I'm going to factor this 3rd degree polynomial. It was a 4th degree polynomial. Now it's a 3rd degree polynomial. And because they said it's multiplicity 2, that means 1 is a 0 again. So we'll do it again. So bring down the 1, multiply, add, multiply, add, multiply. And notice, sure enough, it worked a second time. So now we have x minus 1. Notice it occurred twice. You can write that as x minus 1 squared if you'd like. And we're left with x squared plus 6x plus 58. Okay, we've got 2 down, 2 to go. Now this one doesn't look to me like it factors. 29 and 2 multiply to 58, but they don't add to 6. So I'm going to use the quadratic formula to find the last 2 zeros. Remember, once you get down to a quadratic formula, you can always use a quadratic formula. So minus b plus or minus b squared. Notice a is 1, b is 6, c is 58. B squared minus 4 times a times c, all over 2 times a. Let's see, we're going to get 36 minus 232. Let's see, when we subtract that, we get minus 196. Notice these last 2 zeros are going to be complex because of the minus sign there. So let's see if we pull that out. Let's see if we can simplify this a little bit. This will be I. Let's see, I believe that 16. Let's see, this is 16 doesn't go into it, but this is actually 14 squared. So this will be minus 6 plus or minus 14i. Each of these is over 2, so it looks like the other 2 zeros are minus 3 plus or minus 7i. Okay, that's from the quadratic formula. Now, if they ask for the zeros would be 1, 1, minus 3 plus 7i, minus 3 minus 7i. But if they ask for it in factored form, we'll say x minus 1 times x minus 1 or x minus 1 squared. And remember, it's x minus this 0 and x minus this 0. You can stop there, but I like to multiply this through and get rid of those inner parentheses. So this will be x minus 1, the quantity squared, x plus 3 minus 7i, x plus 3 plus 7i. So this would be the polynomial in factored form.